This is problem 11 from Chapter 2 of the CFA Institute textbook, Corporate Finance, A Practical Approach, 2nd edition. Here we're given an investment has an initial outlay of $100 and after-tax cash flows of $40 annually for 4 years. $100 out, $160 coming back in. If they do a project enhancement, it'll increase the outlay by 15, so it'll be 115 out instead of 100, and the annual after-tax cash flows will also increase by 5. As a result, it's asking you what will happen to the vertical intercept of the NPV profile. Well, let's construct an NPV profile. First thing we need to do is graph out these cash flows. Time period, cash flows for the base, and cash flow for the enhanced. Alright, 0, 1, 2, 3, 4. The base case, $100 out, $40 back in each year for 4 years. The enhanced case is $115 out, but you're going to get $45 back instead. So you spend an extra 15 and get back a grand total of 20. So now that we have these numbers, I can construct a NPV profile for both the base case and the enhanced case. Now, how you construct an NPV profile is pick some interest rates from 0 up to however high you want to go. And then you graph them, okay? So the NPV at 0 is simply the sum of all those cash flows, but in Excel it's easier to just do this and set up a formula that I can copy. So the NPV of these cash flows minus the cash flow at time 0. Plus a minus here. So at 0%, this is worth $160, all right, because its present value and its nominal value are the same. So 160 minus 100 gives you 60, and then I'll just take that up with all these different. I'm going to just show one decimal place. With the enhancements, what we see is a slightly different profile. Alright, so if I graph this using an XY graph, the XY graph on the x-axis is the discount rate, and on the vertical is the NPVs. So an NPV profile is just a graph at different discount rates of the net present value. Alright, so for the base case, this is the light blue line here. What we see is that there's been a shift in the slope of the line. The enhanced actually went higher. So if we're trying to interpret this, the enhanced project, so as a result, the vertical intercept is where the profile now intersects with the vertical line. As a result, the vertical intercept of the NPV profile shifts up. Okay, so it went from the light blue to the red, it went up. We got that. And the horizontal intercept shifts left. It moved to the left. So that's your answer on this first one. If it shifted up, and the horizontal intercept shifted right, then that would mean that the slope didn't change so much as everything just shifted out that way. And then the third option is down and the horizontal intercept shifts left. The vertical intercept is, if these numbers had stayed the same rather than going up by 5, the vertical intercept actually would have shifted down, because the sum of these numbers, that is the undiscounted numbers, would have decreased. But this went up by 15, and because each of these went up by 5, the undiscounted amount went up by 5, that's how much the line shifted up on the vertical. It went up 5. And it's shifting over here to the left because the IRRs of these two are different. If I calculate the IRRs for both of these, we could have had it shift Notice the IRRs are different. The internal rate of return is the point at which these lines are intersecting the horizontal axis. The blue line intersects the horizontal axis at 31% required rate of return, and the red intersects it at 30%. Now, depending on how we had structured all of this, you could see in this instance, if this had only gone up, the cost had gone up by 5, then we would have had a different answer. That would have meant that it would go both up and the horizontal intercept would shift to the right. So it's really the relationship between these numbers and the changes in the numbers. All right, but we can easily just graph something out, and you can see that the correct answer, the vertical goes up, the horizontal goes to the left.